Thanks, Will. I'm going to be talking about a project that we began about 3 years ago when we realised if we're trying to stop insects coming to the country, we need to know which ones could come to the country, and that work hadn't been done. We were waiting for the work to be done, and we thought, no, let's do it ourselves. Let's secure the money. We secured a couple of $100,000, teamed up with Monash University. The funding came mostly from the Ian Potter Foundation, and we began this project to systematically identify the highest risk species and their likely entry pathways to try to stop them entering into Australia. This is for insects. Now, the method, this is a well-established international method to really start from the ground up, work out all of the potential insects that are out there in the whole world, and then look at those ones which may have impacts and classify those impacts, and to look at the pathways. So you can see the pyramid working your way up from the bottom, and starting at, and then once you've done that second tier, B and C, then do the risk assessment and risk profiles. Now, we weren't going to go right to the top because, particularly at the top, that's the work the government does around the detailed risk assessments of individual species. We're going to do the groundwork to narrow that pool down. And these are the results. We're near the end of the project now. The rectangles there, the blue rectangles, the lightest colour is the pool of all known classified insects in the world. Well, we have a 1 million described, 4 to 6 million there, but what we did is looked at all the literature, and because the best predictor of an invasive species is whether it has established and caused harm in other parts of the world outside its native range. And so we assembled that, and that's where we came up with the 2,800 species. There was some evidence in some countries of impact. And then we narrowed that down to negative impact, and then we narrowed it down further where there was frequent evidence that was worth investigating further. So that pool, 247, it sort of changes a little bit as we do a little bit more work and fine-tuning and do the peer review process. 17 of those species, including yellow crazy ants, red fire ants, European wasp, are already in Australia, but that's not many really. But so it means there's a lot more that could come in. We ran a workshop, a week-long workshop to, once we assembled the data, to make sure that we were on the right path, but also to primarily establish what the impacts were using a methodology by the IUCN. I'll come to that next. That was most of the work, not only from the workshop, but there was about 3 or 4 months of voluntary work afterwards from this pool of international and national experts on insects, and particularly the method. And we also did some scenarios setting as well to see if that tool would be useful for seeing how the invasion actually would unfold when it arrives, which was really a good tool for your contingency planning. This is the assessment methodology. On the right-hand side, you can see the different classes that the experts determined. At least 2 experts did every species in the pool. Well, actually, we had to narrow it down. We've so far gone in detail for about a bit over 120 of those 240 of the most likely candidates have been fully assessed. We want to complete the job. And so using that, what's called ECAT, Environmental Impact Classification for Alien Insects methodology. The methodology, hasn't just been applied to insects, it could be applied to all alien taxa. So we were applying it to insects for the first time, so we had to tweak that a little bit as well. That was part of the process to make sure it's is usable for other people. Now, the results of those 240, this is what we're finding. Of all of the orders in the insect family, we've got about 10 that stand out. And the one that stands out the most is the Hymenoptera. They're the bees, wasps, and ants. They're the ones which have the most, the large number of species with strong evidence of environmental impact. This is what they do. Of the 124 that we've assessed in a lot of detail, mostly the social Hymenoptera, the social bees, the social wasps, and ants, which are social on the whole, beetles. There's just some stats. I won't go through it in detail. All this is, we've got the summaries publicly available, and these will all be turned into scientific papers over the next 6 to 12 months as fully published and peer-reviewed. Some standout examples. We did some profiles of some really ones which were a little bit alarming or hadn't been on the radar. This is one in particular that hadn't been on anyone's radar in Australia that we were aware of. It isn't in the top 40 pests that the plant pests that the Department of Agriculture identified. The harlequin ladybird. It's already invaded most countries in the world. I think Australia is the last one, except for Antarctica, the last country to be invaded. New Zealand, it invaded in a very short period of time. This is a real worry because it's a generalist feeder. It could harm a lot of the beneficial insects and could cause massive agricultural and environmental impacts. So we need to start to be on the lookout for this. Gypsy moth is another one that stood out. That it was on our radar, but mainly as an agricultural pest. And I think what this work has done is confirmed it's also a serious environmental pest. We also did a pathway analysis to identify where these insects are coming in. You're looking at the publicly available data. And if you look at this graph here, the dots represent, the bigger the dot, the more frequent likelihood the species could arrive. And you can see the Hymenoptera is coming in all of those common pathways. These are the top 12 out of the 24 pathways that through the classification system we use. So it's going to be a real challenge to keep the Hymenoptera out. There's a bit of a breakdown. I better speed up because we're just near the end. And we also developed some recommendations just to make sure we are using this project to actually further refine the risk assessments for each of those candidate species. We're doing work on identifying in detail the specific pathways for Australia. And for particularly social Hymenoptera, we need to be accelerating efforts to prevent them spreading in Australia. We already have an invasive ants plan, but we need to go beyond that. The second part of it is we need to extend this process, which is repeatable, transparent, and systematic for other species. We want to extend this to fungi of plants and animals. We're seeking funding for that. Already ABARES is doing some work on prioritising pests, but it's only a one-off rapid assessment and it doesn't use this methodology. And then finally, we need a platform to house that. So I want to thank all of the funders, including the Federal Department of Agriculture and the Queensland Government, who are getting some outputs from this as well. Thanks.